and welcome back. Now finally the most interesting part of creating the neural network here. How can we do hyperparameter tuning? So this is something which you might have used in the past when you did normal, let's say, machine learning models, right? So you learned maybe about grid search CV, which is available, or random search CV. But how can we actually apply those things to a model, a deep learning model, right? Or a deep neural network. So there is actually something we can use, which is a so-called Keras tuner. Maybe you've heard of it, maybe not. If not, then of course, now get excited because here we're gonna tune our model. Okay, so we go to code here, and this is something you probably have to install, because if I, for instance, say I want to import, let's call this import Keras tuner, I'm not sure, I don't think it's available in Google Colab by default. So if I import that Keras tuner, and I see that the module named Keras tuner is not available. Okay, so that's something I need to install first. Okay, let's call the pip install. Let's call it, let's say pip install Keras tuner. Or let's say actually -u Keras tuner, tuner, like that it's called. Okay, so let's actually run this and let's see. And here we go. You run the pip install command. Also something which is really nice. You can run it in Colab exactly the same way as you would do it in the Jupyter Notebook, by the way, right? You can also use pip install command there and simply install the libraries in here. And you can see it's collecting this Keras tuner, in this case from this website, and it's simply downloading this specific package so we can use it. Okay, you can see that it's done and it's successfully installed. Great. So now it's available to us, and then of course we can now import the package. So let's say in this case from Keras tuner, so we don't want to import all the modules from the Keras tuner. I simply say from Keras tuner dot, in this case, tuners, I want to import, in this case, the random search. You will see, and it's finding it. Okay, that's fine. And let's actually just make sure that it works. If I run this now, you can see that now we don't get any errors anymore because we have installed the Keras tuner library in here, right? The Keras tuner is installed, it's available for us, and now we can use it in this case, in this Colab notebook. Of course, if you terminate this notebook and you create a new notebook here on Google Colab, then of course this is not installed and you need to reinstall it, right? That's of course something which you would not have to do if you run it on your local computer, right? Then you install it one time, and if you use the same environment in your same Python environment, then it's available, of course, forever, by the way, right? Okay, so now we have imported the random search. And now let's figure out how we can use this random search to really get the best out of our model, really to tune the hyperparameters in the model. So let's say we at first need to create what is called basically the model, but the model this time for the Keras tuner to work needs to specify it in a function. Okay, so the function, so we call def here and call this function build model like that, and then we specify in this case the hyperparameters, right? And that's why I simply call HP. Not for horsepower, but for hyperparameters. Of course, you can also use a different name if you want, right? Could use a different name instead of HP if you want, but it's not necessary. You can use it. You can also type in hyperparameters as a word. You can name it differently, totally up to you. But you need to specify something here, okay? In this case, let's say HP for hyperparameters. And now within this function, we define the model. So we say model, in this case, model is equal to keras.sequential, like that. And this time we're gonna do it differently, right? So the whole time we did it like that, and then we put it in a list, but this is something we don't do now. Okay, so instead we use the normal approach, which we have talked about before, which you might be familiar with, which is simply adding the layers. So I simply say instantiate the sequential here. So the sequential simply means, okay, we got basically the corpus of the model, and now we need to add the layers. So we simply say model.add at first, and let's say so keras.layers, and I'm referring to the average pooling 2D. So average pooling 2D, there we go, which we have done in the last model as well. So 6, 3, and then say for the input shape is equal to, and now we can specify it here. It's 300 by 300, so the image width and height, and 1 color channel, right? Okay, so we got this, and that should be it. Okay, and now we do the following. We go through a loop here, because what this random search and then this hyperparameter tuning allows us to do is it allows us to try out different kinds of filters, for instance, right? Or different kinds of amounts of convolutional layers. For instance, what we said here if we scroll up to this model again, we said, okay, we have 2 convolutional layers. And we also said this first convolutional layers will have 64 filters and the second one will have 32 filters. But how do we know that 64 and 32 are the best parameters? How do we know that 2 convolutional layers are the best? What about 3 or 4? Maybe 4 is better, maybe 3 is better. We don't know. So we can try that, right? We can tune this, try different kinds of combinations using this Keras tuner here. So what we do is we start with this average pooling, so we keep this fixed. Okay, this is a good start, so we keep this fixed. We don't change this. But now we simply say, using a for loop within this function here, we can simply say for I in range, and then we simply can say hp.integer. Again, if you change it here, the name, you need also change it here. Okay, but we specify, okay, this hyperparameter will be of type integer, so only whole numbers are available here. And we simply say, okay, we name this integer, let's just see, no, dot int, int, you spell it correctly. So int, okay. And now for these integers here, we need to first give it a name. Let's call this conf layers. So conf lay, okay, so conf layers, conf lay, whatever you can call it differently if you like, but convolutional layers if you want. But you need to specify one name for this integer. And then you can simply say, okay, that is my name. And then what is the minimum value? So min value, let's say, is equal to 0. So start with 0 convolutional layers. And the max value is equal to 3. Okay, I don't want to make this size too big because otherwise it might take too long to train here. But basically what you say here is you create a loop here and you specify, okay, we have either 0 convolutional layers, we have 1, 2, or 3 convolutional layers. So these are the different kinds of options you can use, you can try when you tune the network. That's basically what we tell it here, okay? All right, so we got this. And of course, because here we got a for loop, double point here, and then here we say, for this, we will say model.add. And what do you want to do? Well, here we only specify this will be of type integer, the name is conflay, right? And the minimum value is 0 and the maximum value is 3. But now we need to use those values by adding convolutional layers, right? So we say model.add, and then we say keras.layers.conf 2D, so convolutional 2D, that's fine. And then we specify here, again, a hyperparameter. We say hp dot, and it's called choice, okay? It's called hp.choice here, like that. And for this choice, we simply say, okay, let's actually use an f string here and say this will be, let's say, the amount of conf layers. So let's say conf layer, lay, let's call it conf lay again, conf lay, and then actually it's not the layer, sorry, it's a filter. So let's say conf, and let's call this conf, let's call it, type in here and say, in this case, this will be the I here, because we use this in the loop for I in range, so conf I, and simply say then filters, okay, conf filters, okay, like that. That would be the name here, and then we can simply type in a list of different kinds of filters we want to check. So let's say 16, 32, 32, and 64, okay, 64, not 54, 64 here, and then we say, okay, we got, in this case, a kernel size of 3, and then we specify the activation. So activation here is equal to, and I'll say a relu, okay, like that. And let's just give me a second because I think I got one spelling here. So keras layers, control D, and hp.choice, that's also fine. And then I should actually close the layer here. The first layer is closed here, I guess. The hp.choice is closed here, yes. Just make sure that I got the parentheses correct, okay, like that. So that is that basically. Yeah, okay. So this is this structure, and then we add additional layers, like in this case what we had, the normal ones. Let's say a model.add, and then we want to add here a max pooling layer. So keras, after the convolutional layers, we want to add keras.layers.max pool, max pooling 2D. So max pool 2D. Here we go. And then we simply specify here the pool size is 2, 2. Okay, so the default one actually, and then we add model.add. Again, we're using a keras.layers, a dropout layer, to avoid overfitting dropouts. This also will be 0.5. Of course, you can also use, for instance, this additional more tuners here, like that, and same structure for the dropout layers and so on. But let's actually stick to the dropout 0.5. That's fine for us now. And then we simply say model.add keras dot layers dot flatten like that. And again, we flatten the network so we can use dense layers then after that. So we simply say now model dot add, and again the same structure as we have before. To don't specify the dense layers or the amount of dense layers in advance, we simply say model dot add, and then keras dot layers dot dense like that. But now we simply use the hp.choice command again. So hp.choice here, here we go. And for this choice, we simply say this will be our dense layers, so let's call them dense. Let's call them dense lay, okay? Same structure as above, so, but of course, then I would use a capital L. Dense lay here, that's the name here, and then we simply say, okay, how many dense layers do you want to check, or what kind of dense layer, or number of neurons in in this case, number of neurons in dense layer you want to check. Let's call this 64 neurons, then I want to try 128 neurons, 256 neurons, and let's say 512 neurons, and maybe also 1024 neurons, okay? So these are the kind of neurons I want to check. Then I close this parenthesis here and say the activation is equal to ReLU, like that. Okay, so we can close this here as well. And then we add at the end, of course, model dot, in this case, add. And then again, it's keras.layers.dense here. And of course, now at the end, we got 3 classes. So we got 3 neurons here again. And the activation is equal to softmax. Okay, so that will be exactly the same here. And then, of course, we need to compile this model. So let's actually go in here within the function itself. Same is true. So we say model.compile, like that. And we compile the model and simply say the optimizer is equal to Atom. Then the losses here, we simply say the loss is equal to keras.losses. We do exactly the same as we had before. So losses dot and then sparse categorical cross entropy. Okay, we instantiate that. We can adjust the default settings if you want within the parentheses, but for us now that's fine. And I call matrix is equal to accuracy. Like that. Okay, let me scroll up here like that. Okay, so that is what we do, and then we have that as well. And then of course then we need to also return this model, okay, because this is what we do basically in the function itself. Okay, and now we have defined the function one more time. Let me actually get rid of that. So the function itself, which we need in order to use this keras tuner, because of the random search from the keras tuner. So keras tuner allows us to tune our hyperparameters, and we need to using the random search, and we need to give it a function. This function is kind of similar to the network which we already created. For instance, up there, right? It's kind of similar, but it's not the same, because this convolutional neural network type 2 has pre-specified parameters. Like for instance, we got the first layer got 64 kernels. Or filters, sorry, kernel is the second argument. 64 filters and filter, in this case, a kernel size of 3. And then we got 32 filters and a kernel size of 2. And then we got a dense layer with 128 neurons, for instance. But we know what we don't know in advance. Are these actually really the best combination of parameters? 64, 32, and then 128. We don't know. That is why we can use this option here, this random search from the keras tuner, and create a function here. And this function allows us to, well, change or try out different combinations. And what we do here, for instance, this is in this for loop, we simply say we want an integer here from the hyperparameter, which will be a value between 0 and 3, and try out those combinations here for the amount, in this case, of convolutional layers. Because we can say, see, in the for loop, we simply say we want to have convolutional layers, and we want to have either 0, 1, 2, or 3, right, of those convolutional layers. And for the convolutional layers in this loop, we want to try out different kinds of filter sizes. So let's say of 16 filters, try out 32 filters, try out 64 filters, right? So these are the combinations which are available for us. Okay, and then we do the same here, basically down there, for this dense layer. So for the first dense layer we create after flattening the data, we simply say, okay, please give us a dense layer, but try out different combinations here. Let's take a look. What is the output if you use 64 neurons in this dense layer? What is the output if you got 128 neurons? What when 265, and so on, right? So try out different kinds of neurons in this dense layer. That is what we do. Okay, so we have defined the function. That's great. And now we can basically define the tuner object. So let's say the tuner object is equal to, and now we call random search, which we imported from the keras tuner up there, right? In cell, or in this 26 run. And now we specify something. And if you open parentheses, you already get a preview here. You need to give it a model here, objective and max trials and so on, right? So in this case, we simply say the random search here, the hypermodel itself is, in this case, our model function, so the build model. Of course, if you name this differently here, up there, then you need to specify the exact name here, right? So that's basically the name of the function, and then we simply say, okay, the objective is what you want the model, what was the target of this tuning, right? So what you want as a target, this is the objective, and the objective or the target is actually the validation accuracy. So let's call it val accuracy, right? Because this is what we want to optimize. So there are basically two accuracies. There's the training accuracy, if you want, so the accuracy, and there's the val accuracy. The validation accuracy, of course, will be then exactly the parameter which we want to optimize our model for. Okay, because we want to at first train on the training, but validating the model on the validation data, and this, of course, should be the maximum, right? So that is why we specify this is an objective. Okay, so we got this as well, and then of course we need to specify the trials. So the max trials simply means, okay, trials, where we go here, trials simply means, okay, how often should I try different kinds of combinations? That's basically what you specify here. And I'm specifying 32 here, but of course you can choose different kinds of trials here if you want. It also depends, of course, how long do you want to train the network, right? So for me now, I simply use it that way. So I say, please, this is the function. You got here different kinds of options. You can combine those. You can use different kinds of convolutional layers. In this case, different kinds of filter sizes for those, different kinds of amounts of convolutional layers, and also different kinds of neurons in the dense layer. That is what we basically train here, right? And of course, as said, you can also apply this to different other kinds of layers here if you want, right? We do it only for 2 of them here, as an example. But please be aware that the more and different kinds of combinations you use here, and also the more trials you use, then of course the training will take longer, right? That's simply the case. So that's basically what we define here. And then finally, what we do is we simply then run this search. So you can simply say the tuner is defined. And now if you search something, tuner.search, here we go. And now tuner.search. And for the search, we simply type in now the train data. So train images, as well as train labels here, labels like that. And then the validation data here in this case, it will be the test images, as well as the test labels, like that. Okay, so we got this as well, and then we can specify the epochs. In this case, let's say epochs is equal to 10, so we run it a little bit longer, and the batch size is again equal to 32. Okay, that is what we specify here. If I scroll up here, that is what we do. Okay, so we build the model. We also compile the model within this function here. We return the model. And then we say the tuner is a random search, which we imported from the Keras tuner. We say this is the function you can use the random search on. The objective is the val accuracy. You get maximum of 32 trials you can use. And now we basically then run this tuner here by fitting it with the training data, specifying what's validation data, and simply say what are the epochs and what is the batch size. Okay, and now let's actually run this. And let's just see, and I got a name, validation data is not defined. Let's just see. And what's missing is I can already see it, validation data, and there is no equal sign, which I missed, right? So type in an equal sign here, and let's try to run that again. Let's run this, and let's just see, and you can see the epochs. It's starting to train here, and let's actually see and wait until we're done for this tuner. And okay, trial is complete, and you can see that now it starts and continues with the next hyperparameter tuning. Okay, and I will skip this now, and we'll see this in the next video, what kind of accuracy we get and what the best parameters are. Okay, so that's it for this video. It's quite long, I know, but hopefully it was interesting, and hopefully you were able to follow along. As always, thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys.